Welcome to the third section of the course. Until now, we've introduced the problem and established the foundational architecture. Now, it's time to start building our prototype. In a real-life scenario, prototypes are typically created quickly and cost-effectively to simulate and test the actual product to see how it will look and behave. Throughout this course, however, we'll take our time and carefully walk through each process step, ensuring you understand how to create a prototype. We'll start this section by exploring the settings of OpenAI's GPT models in the so-called Playground. It helps experiment with the models and their parameters without the need for coding skills. Once we're comfortable with the Playground and have tested our system prompt to ensure it produces the desired responses, we'll use Streamlit, a robust Python framework. Streamlit is widely used by data scientists, AI, and ML engineers because it simplifies the development process and allows for the quick creation of dynamic data apps with minimal effort. It's particularly useful when you need to build prototypes swiftly and efficiently. In the following lectures, we'll connect Streamlit to the OpenAI models and build our interview tool prototype. I'll also show you how to upload your project to GitHub and deploy your Streamlit app. By the end of this section, you'll have created a fully functional prototype that meets our requirements. Let's get started. The GPT Playground is an excellent tool for testing and exploring the capabilities of your chosen model to ensure your concept is achievable. With this platform, you can interact with different versions of the GPT model, experiment with various prompts, and fine-tune your approach to get the desired outputs. Now, it's essential to note that when we test the functionality of our system prompt, we should use the Playground rather than ChatGPT, as the Playground functions similarly to the API, which we'll use in upcoming lessons. This makes it a more accurate environment for testing and refining our system prompts before integrating them into our application. Let's begin by introducing some crucial settings. To access the GPT Playground, navigate to OpenAI's landing page and log into your account. Select the API option, and you'll find the Playground. First, there's the Model setting, where you can choose among a range of models, from the most recent to the legacy models in the GPT family, accessed from the Show More Models option. Next, we have the prompt structure, which includes the same message types we discussed: system, user, and assistant messages. Then, we navigate to the right side of the screen and find a parameter called temperature. This setting controls the randomness of the model's output. Lower values make the output more deterministic, while higher values increase randomness, creativity, and the likelihood of hallucinations, a problem we'll discuss in future lessons. If you increase the temperature to the maximum, the model may produce output that isn't readable. Let's do a quick test demonstrating the outcome of setting the temperature to 2. Use the following sentence as an input. Tell me about a typical day for a data scientist. Running it shows that even the most recent model tends to produce nonsensical responses when the temperature is too high. Therefore, we should keep the temperature below 2 even for the most creative tasks. Moving on, we have maximum tokens. This allows us to control the token limit discussed in the previous section. It specifies the maximum number of tokens, including the prompt and the generated completion, with the exact limit varying by model. Another vital setting we need to mention is stop sequences. These are strings that tell the model when to stop generating further tokens. It works by defining specific phrases or characters that, when generated, will halt the model's response. They can help structure responses or prevent the generation of unnecessary text. For example, if you're generating answers to frequently asked questions, you might set the stop sequences to common closing phrases like, "Let me know if you have any more questions," or "I hope this helped you." This way, the model outputs the answer and stops before generating these phrases. Next is a parameter called top P, also known as nucleus sampling. It determines the smallest set of most probable outcomes, whose cumulative probability sums to a given threshold. Like the temperature, it controls the randomness of the response. But while the temperature dictates how randomly the model picks a token from a list with possible ones, top P determines how long that list is. To illustrate this, let's say we've asked a model to determine the next word in the sentence. The sky is. Let's assume the model provides the following probabilities for the next word. With a top P of 1, all possible words, even doubtful ones, are included. As the value decreases, the options are also reduced. So, if the value of top P is 0.6, our list would look like this. Now that we have this list, the model will pick one of the words based on the temperature. If the temperature is higher, the model is equally likely to choose any filtered words. If the temperature is lower, the model is more likely to select words with higher probabilities, such as blue. In the following lecture, we'll examine some scenarios in which different top P and temperature values would be helpful. Lastly, I'll discuss two more adjustable parameters: frequency penalty and presence penalty. The former reduces the model's likelihood of repeating the same line or phrase. The latter encourages the model to introduce new topics by penalizing the presence of already mentioned tokens. And that concludes all the parameters we can tweak at the playground. See you in the next lecture, where, as promised, I'll take a quick detour and walk you through several scenarios requiring different temperature values and top P parameters. Welcome to this lesson on optimizing model settings for different use cases. We'll explore how to adjust the temperature and top P settings to achieve optimal results for various tasks. Let's dive in. Imagine that you're working for a brand new startup. The team is small, and everyone wears multiple hats to keep things running smoothly. As the company prepares for an upcoming campaign, you find yourself juggling different roles, from marketing to data analysis. You can't manage everything alone, so you'll have to leverage the OpenAI API to assist with the different tasks. Your first assignment comes from the Chief Marketing Officer, who needs you to brainstorm and suggest fresh campaign ideas. For this task, you'll need your AI assistant to be as creative as possible, sometimes even thinking outside the box. To achieve this, we'll set the temperature a bit higher to 1.1 and top P to 1. This configuration allows the model to take risks and generate unexpected, experimental ideas. Of course, this means the output might be a bit wild at times, but that's often where true creativity begins. Now that you've come up with a campaign idea, you'll need to create a marketing copy, which will also require some proofreading. You'll want the model to be more precise, but with a bit of finesse in the output. So, we'll dial the temperature down to 0.3 and set top P to 0.5. This configuration strikes a balance. It keeps the model mostly on track, following grammar rules and maintaining clarity, but still allows for a touch of elegance in phrasing. Great! We now have the campaign idea, blog post, and articles done using our models. But now the marketing director has developed a new concept. Why not include a coding challenge in this campaign? The software developer has already crafted some challenges. Your new task is to evaluate these by solving them. So, let's configure our model. We need the LLM to have laser focus and deliver clean and reliable code. That's why we'll keep both the temperature and the top P at 0.3. This setup is ideal for generating code snippets, solving programming challenges, or automating simple scripts. Great job! The marketing campaign was successful, and now the company is left with a huge amount of data that needs to be analyzed. The goal is to identify the ideas that delivered great results and the ones that were less effective so that the marketing team can improve their approach for the next campaign. We'll use our model again, but this time, accuracy is even more crucial. Even the slightest error could lead to significant miscalculations. To ensure precision, we'll reduce the variability further by setting the temperature to 0.2 and top P to 0.1. This setup ensures the AI delivers precise and consistent results, making it ideal for data-oriented tasks like scripting and SQL querying. After analyzing the data, you've gained valuable insights, and now you've received an email from the CEO. It's time to present your findings to all the managers. To prepare for the presentation, you've decided to use AI again to help you summarize the information, which you'll transform into a report. In these cases, you want the AI to remain accurate, while being flexible enough to make content more readable. Here, a temperature of 0.3 and a top P of 0.5 strikes the right balance. It ensures the output is precise while still allowing the AI to make thoughtful adjustments. You did a fantastic job with the presentation, impressing the CEO. As a reward, you've been entrusted with an exciting new project, designing a chatbot that can answer potential customer questions in a natural and human-like way. We want the interactions to be engaging and dynamic, so we set the temperature and top P to 1. This way, you allow the chatbot to generate varied and dynamic replies, making the conversation feel more human-like. With all your hard work, you've become the real MVP of the startup. Thanks to your skills and clever use of AI to tackle every challenge thrown in your way, the company is now thriving and has hit an all-time high in revenue. To conclude, tasks that require logical thinking, such as coding, benefit from lower temperature and top P settings to ensure precision and consistency. Conversely, tasks that thrive on creativity should have higher temperatures and top P settings for greater experimentation and originality. Feel free to experiment with different settings to find what best suits your use case. Alright everyone, the next lesson will be on the exciting topic of prompt engineering. See you there! Now that we're familiar with OpenAI's Playground and the available model parameters, let's explore prompt engineering. This is a vast topic. In this lesson, we'll focus only on the most essential bits. Once we cover the theory, we'll test our system prompt in the Playground. So, what is prompt engineering? Prompt engineering is the process of designing and refining prompts to effectively interact with AI models. The goal is to craft inputs that produce the most accurate, relevant, and valuable outputs. This involves understanding how the model interprets different prompts and adjusting the wording, structure, and context to achieve desired results and maximize the model's potential. Let's start by going through some of the best practices and tips for prompt engineering. Being as clear and concise as possible. This is vital when creating a prompt. Avoid unnecessary words or complex language that might confuse the AI. Think of it like giving instructions to someone who might not have all the context you do. Clear and straightforward guidance usually works best. Request structured responses from the model. Using a structured format like JSON or HTML can significantly improve the clarity and effectiveness of your prompts. A good practice is to provide a template and include comments within the template to guide the model's output. For example, if you're creating a program that automatically answers emails, you need the response to be in a specific format so that your program can pick it up and insert it into the email. Your prompt might look like this. Start by clearly instructing the model about its purpose, followed by a request for a structured output in JSON format. Therefore, we ensure the response is organized so our program can quickly process. Additionally, we include comments within the JSON structure to offer further guidance, clarifying what each part of the output should contain. Apply few-shot prompting. This step involves providing the model with a few examples of how a task is completed, allowing it to learn from these examples before attempting the task independently, a technique known as few-shot learning. For instance, let's say we need to create a program that generates a quote based on a given theme. In this case, our prompt would include 3 examples, each with a theme and a corresponding quote. The final part of the prompt leaves a blank for the model to fill in based on the user's input, allowing it to generate a new quote that matches the given theme. Specify the necessary steps to complete a task. Outlining the steps required to complete a task can help the model generate more coherent and accurate responses. Going back to the email example, using this technique, we can construct the prompt like this. We instruct the model to extract the email content first and then come up with an appropriate reply subject. Next, it should draft a response to the email and end with, "Best regards, John Green." Finally, the model must organize all this information into a structured JSON format. It's also crucial to give exact commands of what the model can and cannot do. Use phrases like, "Give me only round numbers." Do not write anything after the JSON. Respond only in bullet points. Or, do not include any personal opinions. Allocate complex tasks across multiple models. If your task is more complex, consider dividing it between several models. This approach can help manage the complexity more effectively and improve the accuracy of the outputs. In our use case, the interview tool must perform multiple tasks: conduct the interview, keep track of all messages, and evaluate the end user. A single prompt solution wouldn't be very convenient or efficient for handling these diverse tasks. Therefore, it would be best to divide the process into two separate prompts. One prompt would focus on conducting the interview, ensuring the conversation flows naturally and all necessary questions are asked. The other prompt would handle the evaluation, analyzing the responses and providing feedback based on the user's performance. By splitting the tasks, we can manage each tool aspect more effectively, leading to enhanced performance, accurate evaluations, and efficient use of tokens. Strike a balance between reproducibility and creativity. LLMs have a natural tendency to hallucinate, generating information that is believable but incorrect. Still, sometimes, they produce original ideas or responses that are very useful. That's why hallucinations can be both a feature and a bug. Finding the right balance between guidance and flexibility is critical to ensuring we only get the best of hallucinations without breaking our program. We'll dive deeper into hallucinations in the next section of the course. Alright, you should know it's okay not to nail your prompt on the first try. Writing effective prompts is more of an iterative process than a one-shot deal. You start with a rough idea, then mold and shape it based on what works and doesn't. To give you an estimate, we've dedicated over a month of hard work to perfect our prompt, utilizing more than 7 million tokens. Alright, now that you've learned the art of creating effective prompts, it's time to put that knowledge into practice by testing prompts in OpenAI Playground. That's precisely what we'll do in the next lesson. See you there! In this lecture, we'll examine the final step of prompt design: testing your template. By doing this, we can ensure that our commands perform as expected and deliver the desired results. Let's start by taking the prompt we crafted in the previous section and pasting it into the system field in the playground. As discussed, the curly brackets in the prompt indicate placeholders where dynamic content will be inserted during an interview. To test our prompt's performance, we must replace these placeholders with dummy data, simulating a real case scenario. This lets us see precisely how the model would behave with actual inputs. So, as our dummy data, let's use Amazon instead of company, and Olivia for name. Let the position be data scientist, and her level as junior. For skills, we'll input Python machine learning and data analysis. We'll also provide 2 dummy interview questions to simulate the interaction. Notice how we've removed the chat history. This is because the playground handles memory independently. We'll leave the top P and temperature to 1 because we want our interview AI to ask questions creatively and make the interview flow more naturally. Once you've filled in the placeholders, test the prompt. please pay close attention to the model's output and evaluate whether it meets your expectations. Let me show you two mock interview examples, one in which the model correctly understood our intentions, and another in which it misinterpreted them. In the first example, the model understands the initial setup and begins the interview appropriately. It deviates, however, by generating both questions simultaneously rather than maintaining a more interactive back-and-forth exchange. This means the model treats the interview as a single batch process instead of simulating a natural conversation flow. This isn't ideal for our goal of a realistic interview experience, where questions should adapt based on the interviewee's previous answers. On the other hand, in the second example, we used the same prompt but saw a better outcome. Here, the model starts with a greeting and then asks the first question, waiting for the user's response before proceeding to the next. This structure aligns more closely with our desired interview flow, where the conversation unfolds more naturally. It allows the interviewer to adjust their questions based on the interviewee's previous answers. As you can see, the model's behavior may vary. That's why we need to modify our template and then try again. We can solve this problem by simply adding the following sentences to the prompt. Ask each question individually, creating a conversational flow rather than presenting all the questions simultaneously. Alright, now, let's add the message and test our prompt again. It works! As you can see, the interview follows our guidance, resulting in a more interactive and realistic conversation. For those following along, I encourage you to try this yourself as a hands-on exercise. Run a few mock interviews using the adjusted prompt and see how the changes impact the interaction flow. And don't stop there. Experiment with further adjustments to the prompt to see if you can make the interview flow more smoothly. Remember, testing in the OpenAI Playground is not just about verifying that the prompt results in good model responses. It's about fine-tuning and optimizing it. Experiment with different inputs, tweak the settings, and observe how small changes can impact the model's responses. This iterative process is crucial in developing prompts that are not only functional, but also highly effective. Great! Now that the theory is in place, we'll dedicate the rest of this section to creating the prototype in Streamlit. See you there!